Okay, hello everyone. We are discussing about application of Fourier transforms. In our last class, we have been discussed in detail about to find the solution of one-dimensional wave equation. In detail, we have been discussed. In detail, we have been discussed. Okay, I hope you have been written the note. In today class, we are going to discuss another problem, that is your find the solution of heat equation using Fourier transform. Okay, so here you consider this is a substance or a rod. This is your hotter end, and obviously this will be cooler end. So heat will be flow from this side to this side along x-axis. So at a particular point the value of the heat will be different. Okay, so if it is so, then what will be the solution of this problem? So let's start. It is well known that one dimensional heat flow differential equation is written as this one: del by del T of u x t. U is represents the flow of heat or heat content for this substance. So the rate of change of heat uxt, which is the function of x and time, will be equal to c square del square by del x square of u, which is the function of xt. Here this is the small u. Okay, let this is your equation number 1. This equation number 1 represents the one dimensional heat flow differential equation, right? We have to find out the solution. That means small uxt, small uxt, small uxt. Okay, we have to find out the small uxt using Fourier transform. Okay, so here the boundary condition has been given, or boundary or initial condition has been given, ux0. That means at time t equal 0, this is your fx. So that means initially at time t equal 0, at a different position the heat is different, or heat content by this substance is different. And as I told, c square is the diffusivity of that substance, c square, okay, which is constant. Now first we have to apply Fourier transform on this equation number 1. So left hand side we have to apply the Fourier transform, right hand side also. So ft, that means Fourier transform applied on this one, del by del T of u, small u, which is the function of xt, and Fourier transform applied right hand side, c square del square by del x square, small u xt. Okay, so this is nothing but 1 by 2 pi root over minus infinity to plus infinity, this one del by del T of uxt into e to the power I omega x into dx. Right hand side will be this much, this factor 1 by 2 pi root over minus infinity to plus infinity e to the power I omega x into dx. Okay, that implies del by del T. See here, integration with respect to x. So del by del T can be taken outside. Del by del T of 1 by 2 pi root over minus infinity to plus infinity uxt e to the power I omega x into dx is equal to c square is the constant taken outside, c square into 1 by 2 pi root over minus infinity to plus infinity del square by del x square uxt e to the I omega x into dx. So here this is nothing but Fourier transform of uxt. U is the function of xt, and here you can see the Fourier transform applied on the variable of x, uxt e to the I omega x dx. So this will be written as capital U omega t. So instead of x we have to write omega. Okay, these things already we have been discussed in our previous class, that basics of the Fourier transform I discussed in our previous class, you can check. Okay, so here where the Fourier transform applied on the x variable. So for the x variable we have to write omega, t is here, and u will be small u will be capital U. You just recall that previously we have been discussed that suppose small fx is there, so Fourier transform upon small fx will be 1 by 2 pi root over minus infinity to plus infinity fx into e to the I omega x into dx, and this will be considered as capital F omega, right? Likewise, suppose ux will be there, so Fourier transform will be written as capital U omega, right? So here uxt is there, so u capital U omega t. And here we know that this is the Fourier transform of derivatives. So second derivative is there, means minus I omega square capital U omega t will be the answer. And may you remember that Fourier transform of f n x, nth derivative Fourier transform is nothing but minus I omega to the power n into capital F omega. Okay, so here second derivative is there, second order derivative, so minus I omega to the power 2 capital U omega t. Okay, so same thing we have to write here. Okay, so already del by del t is there, so del by del t of capital U omega t equal to, this is c square, this much is minus I omega square capital U omega t minus I omega square capital U omega t. Okay, so this value will be minus omega square, because this square means plus I square means minus 1, so minus c square omega square capital U omega t. So that implies here capital U omega t taken this side, del t taken this side, so this one del capital U omega t by U omega t capital U, okay, minus c square omega square del t. Now we have to solve this by taking integration both the side, integrating this one, these two are constant, so taken outside, integration of this one. So this will be nothing but ln log U omega t equal to c square omega square del t means t, let the constant will be integration constant is ln a. Ln a taken this side means minus of this one, so we can write ln of this by a equal to c square omega square t. So obviously this much, if ln this much equal to this much, so only this much will be exponent to this one, and a is going to be multiplied with this one. So U omega t, capital U omega t will be equal to a into e to the minus c square omega square t. Let this is your equation number 2. Okay. In this equation number 2, a is the constant which can be evaluated by using this boundary or initial condition. So in the initial condition, it is given that here we have to write a is the constant which will be evaluated by using boundary condition. Okay, boundary condition, that is ux0 equal to fx. Already here it has been written. Okay, so we have to use this boundary condition. This means that at t equal to 0, ux0 equal to fx, right? Here t means time equal to 0, ux0 equal to fx. That means you just consider when the time starts, that means when the time t equal to 0, the heat is flowing along x-axis direction. That means at the particular x value, at a particular distance, the heat content by this substance is different. So here heat content will be different, heat content here this point at a different x it is different. So here you just think that this is hot end and this is your cold end, and heat flows from this side to this side. So obviously at this point what will be the heat content by this substance or temperature, here it will be different. So only for that at t equal to 0 means when the time starts, this ux0 or heat content at a particular position is represented by fx. Okay, so now we are going to take the Fourier transform of this equation. Okay, just write here. Now take Fourier transform of above equation. Above equation means this equation. So what we are going to write? We have to write that implies Fourier transform of ux0 equal to Fourier transform of fx. Okay, so here we can write this one itself, that 1 by 2 pi root over minus infinity to plus infinity u, which is the function of x0, into e to the power I omega x into dx is equal to, this will be 1 by 2 pi root over minus infinity to plus infinity fx into e to the power I omega x into dx. So here you can see the Fourier transform applied on the x variable. Here x x x, here x x x. So this will be written as capital U function of, instead of x we have to write omega, 0 is there, 0 will be equal to, here instead of small f we can write capital F omega. Already these things we have been discussed in our last class. Okay, so here we found that u omega 0 equal to f omega. Let this is your equation number 3. Now we have to use the equation number 2. This is your equation number 2. We have to use this equation number 2, find out u omega 0. That means if I am going to put t equal to 0 for this equation number 2, I can found u omega 0 equal to a into e to the power 0, right? So from equation number 2, from equation number 2 also we can found that implies u omega 0 will be equal to a into e to the power 0. That implies u capital U omega 0 function of omega 0 equal to a, right? Let this is your equation number 4. Now you just compare 3 and 4. We found a equal to f omega, capital F omega. By comparing 4 and 3, we get the so-called constant equal to f omega. So here using boundary value condition, we found the constant value is your capital F omega. This will be substituted in your equation number 2. Then the general equation or equation number 2 will be, so therefore equation number 2 will be capital U function of small omega t equal to, instead of a what we have to write here, instead of a we have to write f omega. So capital F omega into e to the power minus c square omega square t, right? Minus c square omega square t, right? Let this is your equation number 5. So this is the final general solution of this equation number 1 equation. Okay, so now we are going to consider inverse Fourier transform of this equation number 5, because we intend to find out small ux. See, we intend to find out the solution of heat equation. This is your equation number 1, which is represents the one-dimensional flow of heat along x-axis. So we want to find out small uxt value is how much. Small uxt value. This is our objective that we want to find out. So you just concentrate on this equation 5. If I am going to take the inverse Fourier transform of this equation number 5, here this is the Fourier transform of this capital U omega t is the Fourier transform of small uxt. Okay, if I am going to take inverse Fourier transform of capital U omega t. So obviously I will get small xt. Then right side also we are going to take the inverse Fourier transform and we are going to be solved, right? So to find out the general solution of equation number 1, we have to take the inverse Fourier transform of equation number 5. So what we have to write? To find the general solution of equation number 1, take inverse Fourier transform of equation number 5. Okay, that implies inverse Fourier transform is applied LHS, that is your capital U, which is the function of omega t, is equal to inverse transform also right hand side. Inverse Fourier transform applied on the right hand side, that is your capital F omega into e to the r minus c square omega square t, right? Okay, now this will be written as small u xt will be equal to inverse Fourier transform of this factor. How we can write? 1 by 2 pi root over integration over minus infinity to plus infinity. This factor, that is your capital F omega into e to the power minus c square omega square t, put it in the bracket, into e to the power, as we are taking the inverse Fourier transform, so e to the power minus I omega x into d omega. Okay, already about Fourier transform and its inverse Fourier transform discussed in our last class, you can check. Okay, so if Fourier transform, we have to take e to the I omega t. If I am going to suppose Fourier transform of suppose here I am going to, last class we in detail we have been discussed, you just recall that. Suppose we have a function fx, so Fourier transform of this fx equal to written as like 2 pi minus infinity plus infinity fx e to the power I omega x into dx. Okay, and this is nothing but capital F omega. Then inverse Fourier transform means we have to apply over, if inverse Fourier transform of f omega, that means 1 by 2 pi root over minus infinity plus infinity capital F omega into e to the, here plus is there, so minus I omega x, omega is there, omega d omega. So here inverse Fourier transform of capital F omega is nothing but again the original function fx. Okay, so only for that we written minus I omega x into d omega, right? Then let this is your equation number 6. Let this is your equation number 6. Okay, now here you can see in the right hand side of this equation number 6, e to the power minus c square omega square t, which is the function of omega, one term is there. Here capital F omega is there. Here one another term is there, which is the function of omega. Let's consider this is your g omega, capital G omega. So let capital G omega equal to e to the power minus c square omega square t in equation number 6. Hence equation number 6 will be, what? That implies small u xt will be equal to 1 by 2 pi root over minus infinity to plus infinity. Capital F omega is already there. Instead of this one, we have been written capital G omega into e to the power minus I omega x into d omega. Okay, so this right hand side also can be written as inverse Fourier transform of this factor. Okay, so that implies u x t will be equal to inverse Fourier transform inverse Fourier transform of this one, capital F omega into capital G omega. Let this is your equation number 7. Okay, now we are going to use the convolution theorem, Fourier transform of convolution theorem, whatever already we have been discussed, and we have to apply that theorem on this equation number 7. Okay, according to Fourier transform, according to Fourier transform of convolution of two functions, we know Fourier transform of convolution of two functions fx and gx. This symbol represent the convolution of these two functions. Okay, this symbol, this star symbol, equal to Fourier transform of fx into Fourier transform of small gx, or this will be written as capital F omega into this will be capital G omega. Here small fx is there, Fourier transform capital F, small gx means Fourier transform of gx will be capital G omega. Okay, now we are going to consider the inverse Fourier transform of this one. So here you just write Fourier transform of fx convoluted with gx equal to this much. Now we are going to consider inverse Fourier transform both the side. So what we are going to we can get inverse Fourier transform of this one, Fourier transform of fx convoluted with gx equal to inverse Fourier transform of capital F omega into capital G omega, right? So that implies here you can see inverse Fourier transform of this one. That means only we can get this one, fx convoluted with gx equal to inverse Fourier transform of capital F omega into G omega, capital G omega, or this can be written as inverse Fourier transform. First you write this one, RHS term take to the LHS, capital F omega into capital G omega will be equal to small fx convoluted with small gx. And we know that convolution between the two functions will be written as like this, 1 by 2 pi root over minus infinity to plus infinity if another function u, which is a function of x, which is the function of x, and maybe another will be t, into g of x minus u du. These things already we have been discussed. See, as per the definition of the convolution between the two functions will be written as this way. Okay, so here u is the function of x and t. So that implies here you can see inverse Fourier transform, we found inverse Fourier transform of capital F omega into G omega equal to this much. So let this is your equation number 8. So here I am going to suggest one thing, that these things already we know previously. Okay, so in your exam you can direct write that according to Fourier transform of convolution of two functions we know this equal to this. Okay, let this is your equation number 8. So here 1 2 3 4 5 steps you can omit in your exam, but clearly write in your note these things. Okay, so here we found that equation number 8 is your inverse Fourier transform of this one equal to this. 7 inverse Fourier transform is this one. So equation number 7 and 8, if we are going to be compare, if 7 and 8, then uxt will be equal to how much? This one, right? So comparing, same thing we have to write. Okay, comparing, and next page we have to write. Okay, next page we have to write. So comparing equation number by comparing 7 and 8, we get that implies small u x t equal to how much? This one, 1 by 2 pi root over this one. Okay, 1 by 2 pi root over 1 by 2 pi root over minus infinity to plus infinity small fu g into x minus u into du, right? Okay, x minus u into du. Okay, okay. So we can say this is the general solution of the one-dimensional flow of heat. Up to this much, if you are going to derive in your exam, you are going to get 50 to 60% mark. Then further simplification, what we have to do? So here do one thing, that here what we have to do, we have to find out the g x minus u is how much. Okay, so for that, first we have to find out the small gx, then small gx minus 1. So here you just write one thing, that here you can see that capital F omega is the Fourier transform of small fx. So here we considered capital G omega equal to this much, but capital G omega also the Fourier transform of capital G omega is the Fourier transform of what? Gx, right? Okay, so here you just write g here. G omega is the Fourier transform of small gx. Okay, so first we have to find out the small gx, and then we are going to find out the gx minus u, and we have to substitute in this equation number. This is your equation number 9. Equation number 9. So for that, what we have to do? Previously we know, we considered, okay, we considered that previously we considered that g omega equal to g omega is the Fourier transform of gx. Okay, that is Fourier transform of gx is nothing but is your g omega. Okay, if I am going to apply the inverse Fourier transform on this equation number 10, then by applying IFT on 10, we can get, here you can see that implies inverse Fourier transform will be applied on the left hand side, on this one will be equal to inverse Fourier transform will be also applied on the right hand side of this equation number 10. So here left hand side will be see ft is there, and IFT of ft will be only gx equal to inverse Fourier transform of g omega. What we have to write? 1 by 2 pi root over, okay, minus infinity to plus infinity g omega into e to the minus I omega x into d omega, right? So this is nothing but the inverse Fourier transform of g omega. Previously we considered that g omega value is nothing but this one, e to the power c minus c square omega square t. This value we are going to substitute over here. Then what we can get? That implies gx will be equal to 1 by 2 pi root over minus infinity to plus infinity. Instead of g omega we can write e to the power minus c square omega square t into e to the power minus I omega x into d omega. Okay, let this is your equation number 11. Now for the further simplification, consider y square equal to 2c square omega square t. Okay, for the further simplification only. So what we can get? So here if I am going to take the differentiation this side and this side, then this will be, that implies 2y dy will be, see, we want d omega, so this will be differentiated with omega. So this will be 2c square into 2 omega uh, 2 omega t into d omega. Okay, so that implies y dy will be equal to 2 to God cancel, we can get 2 c square t omega into d omega. That implies d omega will be y dy by 2 c square t omega, right, is equal to, here you can see, instead of y we can write root over of this one. Okay, so this will be root over of t and c omega root over of t. So instead of y we can write root over of t, here you can root over of t, root over of 2, root over of 2 and root over of c square omega square means c omega, right, into dy is there, into dy divided by 2 c square t omega. That implies d omega, here you can omit the steps in your exam but write in your note perfectly. So d omega will be, here you can see 2 root 2 got cancel, t root t got cancel, and c square c got cancel, and we can get dy by here you can see 2t root over will become up here 2 root 2, so root 2 and here t root t, so 2t whole root over and c. Okay, because omega got cancelled, so d omega we found this much. And if I am going to integrate this one, then ateb omega will be how much? Omega will be, so integration this side the will be y by 2t root over into c. Okay, now we are going to substitute the value of d omega and omega in your equation number 11. What we can get? So hence equation number 11 will be, all right, now put d omega and omega uh, d omega and omega values in equation number 11, we get, that implies g small gx will be equal to 1 by 2 pi root over, already is there, 1 by 2 pi root over minus infinity to plus infinity. Here you can see we considered omega square equal to 2 c square omega square t. That means this value is nothing but y square by 2. Okay, y square, consider this one, so c square omega square t will be written as y square by 2, right? So e to the power minus y square by 2, carefully you have to write, into here e to the power minus I, e to the power minus I is there. Okay, and omega, instead of omega we have to write y by 2t root over into c. So this will be written as, okay, minus, put it in the bracket, will be y by 2t root over into c. Okay, omega value I just substituted over here. Okay, this omega value. So I already is there, y by 2t root over into c, into x is there, into x, okay, put it the bracket over here, it will better. This is I, this is omega into x, into dy value is your, sorry, d omega is your dy by root over 2t into c. So we have to write dy by 2t root over into c. Okay, so that implies gx will be written as 2 pi root over minus infinity to plus infinity e to the power minus y square by 2 into e to the power minus I omega dash. This much value I considered omega dash. Okay, into sorry, this much value, x by 2t root over into x into c. See, this is the integration with respect to y. So we considered that omega dash equal to x by 2t root over into c will be a constant. Okay, omega dash y will be there, y into dy by 2t root over into c. So you just write, put omega dash equal to x by 2t root over into c. Okay, so that implies we can write gx equal to 1 by 2 pi root over minus infinity to plus infinity e to the power minus see here c by 2 root c into 2t root over taken outside, c this c into 2t root over taken outside, so y square by 2 into e to the power minus I omega dash y into dy. Okay, so that implies we can get, here you can see gx will be equal to okay, you write again systematically, c root over of 2t, okay, 1 by 2 pi root over minus infinity to plus infinity e to the minus y square by 2 into e to the minus I omega dash y into dy. So this value will be found by considering this is a Gaussian function. Already we have been discussed what will be the value of the Fourier transform of a Gaussian function. So I have to write this one. Previously we know that Fourier transform of a Gaussian function, that is your e to the minus ax square, is equal to e to the power minus omega square by 4a divided by root over of 2 into a whole root over of 2a. These things previously we have been proved, right? Or I can write this one, Fourier transform of this one will be equal to this one. Okay, or I can write 1 by 2 pi root over, Fourier transform of this one is nothing but 1 by 2 pi root over minus infinity to plus infinity e to the power minus ax square into e to the power I omega x into dx equal to e to the minus omega square by 4a by root over of 2a. You just compare this integral with this one. Okay, you just compare this integral with this one. What we can found? See, this is the Gaussian function. This is also a Gaussian function where a equal to 1 by 2. 1 by 2 pi root over is there, minus infinity to plus infinity is there. Dx here see, here ax square dx, here ay square, a means 1 by 2, y square dy is there. So what is the basic difference between this integral is this integral, that is your here minus I omega dash y, here e to the power I omega x. Okay, so here suppose we are going to consider, instead of omega we consider omega dash over here. So this will be written as capital F omega, right? And suppose this will be written as capital F omega dash. But here this is plus, here this is minus. How we can say that this is also called as the Fourier transform of e to the power minus ax square, and this is also called as the Fourier transform of e to the power minus y square. See, you have to remember one thing. These things already we have been discussed in our previous classes, that suppose in different books they have been written in this way, that suppose fx is the function and we are going to take the Fourier transform of fx. This will be written as 1 by 2 pi root over minus infinity to plus infinity in infinity fx into e to the power I omega x dx. This format we have been studied, and we derived with this format. So this will be your capital F omega will be equal to this one. Okay, but some other books they are considered that Fourier transform of this function fx will be written as in this format 1 by 2 pi root over minus infinity plus infinity fx into e to the power minus I omega x. So there is no uh, problem that if somebody is going to take minus. Okay, if we are going to take this one is our Fourier transform, then inverse Fourier transform of f omega, here inverse Fourier transform of f omega will be written as 1 by 2 pi root over minus infinity to plus infinity capital F omega into e to the minus I omega x d omega. But for this case, inverse Fourier transform will be written as, see, this is nothing but capital F omega. So inverse Fourier transform for this case, uh, f omega will be 1 by 2 pi root over minus infinity plus infinity capital F omega into e to the plus I omega x into d omega. So some books they are considered Fourier transforms plus I omega, some books considered minus I omega x. Okay, so but in our case, previously or whatever the derivations we considered in case of Fourier transform, we considered this format. Okay, you just remember this one for our derivations. Okay, but keep in your mind for future applications, or whenever you are going to follow some other books, may you are going to be face this type of expression. Okay, so here you can see that this expression is equivalent. That means I can say that this is also the Fourier transform of this function. So here you can see minus I omega dash y is there, also it will be considered as your Fourier transform of this e to the power minus y square by 2. So now here if I am going to compare this and this, here a equal to how much? 1 by 2. So the answer will be, carefully you have to watch the integration of this this one Gaussian function will be e to the power minus omega dash is there, so omega dash square by 4 into 1 by 2. Okay, whole divided 2 into 1 by 2. Okay, same thing I am going to write. Okay, just erase it. So you just put it this equation as a number, equation number 12. Okay, equation number 12. So now the equation number 12 will be the equation number 12 will be that implies gx will be equal to 1 by c into 2t root over, okay, this value will be how much? e to the power minus omega dash square by 4 into 1 by 2, because a is your 1 by 2 whole divided by 2 into a is your 1 by 2 root over. So this will be equal to 1 by uh, mm, 1 by c into root over of 2t, root over of 2t into here 2 got cancelled, this will be 1, so it will be e to the power minus omega dash square by 2, right? Now we have to put the value of omega dash. Omega dash we considered x by root over of 2t into c. We have to substitute over here. Okay. So that implies gx will be equal to, this is your 1 by c 2t root over 1 by c into root over of 2t into root over of 2t into e to the power, instead of omega dash square, omega dash is your x by 2t root over into c. So same thing we have to substitute over there, minus x square by okay, this one omega dash, if this one omega dash square, if I am going to substitute over here omega dash square, then this will be x square by 2t into c square. Okay, so x square by 2t into c square into, here you can see, into 1 by 2 is there, into 1 by 2, right? Okay, so that implies gx will be equal to 1 by c into root over of 2t into e to the power, here you can see that 2 into 2 it will be 4, so it will be minus x square by 4t square, 40 c square, 40 c square. So finally we found gx value, gx simplified value is this one, right? But we need gx minus u for this equation. Okay, for the equation number 9 we need gx minus u. So if gx equal to this much, then gx minus u will be 1 by c root over of 2t into e to the power, instead of x we have to write x minus u, so minus x minus u whole square by 4t c square. So we found gx minus u equal to this much. So therefore equation number 9 will be, equation number 9, this one will be u xt equal to 1 by 2 pi root over 1 by 2 pi root over minus infinity to plus infinity, if u instead of gx minus u we have to write this value, that is your 1 by c into root over of 2t into e to the power minus x minus u square by 4t square into du, into du. Okay, so finally we found that implies uxt will be equal to, here root over of t, root over of 2, root over of 2, that will be 2, and root pi will be there, root t will be there. So we found 1 by c uh, c root over 2, root over 2, 2, so 2c 1 by 2c into root over pi root over of t, root over of pi t into minus infinity to plus infinity fu into e to the power minus x minus u whole square by 4tc square into du. So this is the final expression which represents the solution of uh, propagation of heat along x-axis through a substance or a matter, whatever you can say. So this is the final expression. Okay, so thank you so much.